Hi, welcome back. Up to this point, we've concerned ourselves with plotting points on the Cartesian plane. And if you'll recall the diagram here, we saw that we can calculate the shortest distance between those points. There may be times, however, when we've collected a lot of data or data points, and we need some type of visual representation of that to give us information. At other times, we may want to develop a formula from a set of data points that we've drawn a line through. As is the case here, we've basically made a line chart that shows a conversion from kilometers per hour to miles per hour. As you can see in the table on the left here, 100 kilometers per hour is roughly equal to 60 miles per hour, and 160 kilometers per hour is equal to 100 miles per hour. 200 kilometers per hour is roughly equal to 120 miles per hour. One of the key things we're interested in studying when it comes to lines is the slope. As we'll see shortly, knowing the slope helps us develop a formula for a set of data points that we've drawn a line through. And what the slope tells us is how much y changes for every change we make in x. This is sometimes referred to as the rise over the run, because the rise is measured on the y-axis, right, and the run is measured on the x-axis. The formula for the slope of the line is equal to y2 minus y1 over x2 minus x1. The 1's and 2's here represent two distinct points on a line. Let's take a look at an example. Here, we've taken two y points, 160, and subtracted them. And then we divide that by their corresponding x points. The x point that corresponds to 100 on the y is 160, and the x point that corresponds to 60 miles per hour on the y-axis is equal to 100 miles per hour on the x-axis. So if we do the simple arithmetic here, what we end up with is 40 over 60, or 2/3. Just a brief note, you'll sometimes see this written as m is equal to y minus y1 over x minus x1. The y without the subscript is assumed to be y2, and the x without the subscript is assumed to be x2. On an exam or quiz, one of the problems you're most likely to encounter is given by the following example. You'll be given a graph with some points plotted and a line through it, and from the graph, they'll ask you to find the slope of the line. Here we can see that there's a point at x is equal to 1, y equal to 1, x is equal to 2, y is equal to 2, and then so on until you get up to about 5. Having these values, if we fill them into our formula, we can take any 2 points. Here we've chosen the point 5, 5 and 2, 2. For the y values, if you take 5 and subtract 2 from that, you'll get 3. And then for the x values, if you take 5 and subtract 2 from that, you'll get 3 as well, which is equal to 1. Therefore, the slope of this line is 1, because for every 1 unit you change on the x-axis, you change 1 unit on the y-axis. Let's take a look at another example. We have the same thing here again where they ask you to find the slope. For every one of these little slashes, you have 0.2. So you have 0.2, 0.4, 0.6, 0.8, and 1. So if you plot some of these points, you can see that for x equal to 1, y is equal to 0.6. For x equal to 2, y is equal to 0.8. For x equal to 3, y is equal to 1, and so on. So we have our points written down here. If we take our formula again and perform the calculation to find the slope, this is what we get. Again, we can take any 2 points. Here we've taken 1.6 minus 0.6 for the y values, and we've taken 6 minus 1 for the x values of those same 2 points. What we end up with is 1 over 5, which is 0.2. So that tells us that for every 1 change on the x-axis, we change 0.2 on the y-axis. So starting at one of these points, let's take x equals 2 for example. We're at 0.8. If we go to x equals 3, we've gone up 0.2 units on the y-axis. So that makes sense. There are a few more examples we need to discuss to make sure we've covered all scenarios. Let's take a look at this problem. Here you have a horizontal line, and they want you to find the slope of that based on data points. We've written some here along the line, and as you can see, regardless of what the x value is, y is always equal to 2. So let's take our formula and see how that works out. If we take any 2 y points, we can subtract 1 from the other. Since all the y points are 2, what we would have for y2 minus y1 would be 2 minus 2. Here, as you can see, we've chosen the first y value and the last y value because their corresponding points are minus 3 and 3 on the x. So 3 minus 3 is negative 6. Since 0 over anything is 0, the slope we have here is equal to 0. Intuitively that makes sense as well. How much does y change for every change we make in x? And the answer is none. It stays the same. It doesn't change at all. Therefore, our slope is 0. So what would the slope of a vertical line be? As you can see here, x is equal to 2 no matter what y value we're talking about. So if we apply our formula here, we can take any 2 points on the y-axis. Here we've taken point 6, where x is equal to 2, and we've taken 1 on the y-axis, and the value of x for that is also 2. So if we subtract y1 from y2, we have 6 minus 1, divided by x2, which is 2, minus x1, which is also 2. So what we end up with is 5 over 0, and we know that anything divided by 0 is undefined, so the slope of this problem is undefined. So let's take a look at an example of how slopes can be useful to us. Let's say that we're operating a state park and there are hiking trails. On the x-axis, we have the distance of any given trail, and on the y-axis, we have the altitude. So let's say each one of these represents a particular side of a mountain that you're trying to go up. You can see from this example that for the trail M1, it's not as steep, so that might be one that will be a little bit easier. For trail 2, the slope is 2, so that might be a trail for more advanced hikers. And for trail 3, it's pretty steep, so this would be for advanced hikers and climbers. Let's talk about one more topic. Let's say that one half of a trail goes up. Once you're at a certain point up the mountain, you can choose which way to go down. So you can have negative slopes as well. Here you can see that we found the slope of the red line here. It's the steepest of the 3 slopes, but instead of going up, it's going down. If we actually calculate for the slope, we can see that we're calculating the slope between the vertical points 4 and 2. If we take the difference between the corresponding x values of those points, we get negative 4 minus a negative 2, which gives us 2 over negative 2. So the slope here is negative 1. And we know because of the negative sign that it's going down instead of up. Okay, let's go ahead and take a break here. When we come back, we'll start talking about how to find formulas of lines using the slope and other information.